Hello everybody and welcome back. We're going to finish off this topic one, sort of our intro to objects, with a discussion around encapsulation and access modifiers. All right, so let's talk for a second about bank accounts. I'm going to write some notes as I do this, as I attempt to do. Bank accounts. When we think about our bank accounts, we think about probably our name being associated with it, maybe our address, our job and our salary might be in there. Of course, the information like the balance, our credit card or our bank card numbers. Lots of sensitive information, right? Let's put that down. Sensitive information. There we go. All right, so when we think about all of this sensitive information, we want to ask ourselves, do we really want to give strangers full access to all of our bank account information? And when I say strangers, I don't just mean like strangers on the street. I also mean maybe bank tellers that aren't working closely with you, or individuals who maybe are working within the system, but not necessarily that should have direct access to your information. And also, of course, strangers on the street. And of course, I would hope your answer would be no. We don't want to give anybody all this information. This is our own private information, and we want to keep it private. Now, this idea of encapsulation, when we start out, it sort of is a little bit odd because our programs are so small in class. So it does feel a bit odd, and you sort of have to just lean into this idea and trust that we can see long term how encapsulation, how access modifiers could be used to help us. So let's start with this idea of encapsulation, and let's just define it. Encapsulation. So if we're going to define encapsulation, it basically means that we are hiding the state of an object, and we want to, and the ability to control access to data, behaviors, etc. To all that good stuff, right? So this idea of encapsulation effectively is the ability to protect the integrity of an object and its data. All right. So before we had a bank class or an account class, public class account, and you would have had something like public int account number. And now I'm telling you that instead of doing that, we want to have a private account number. And we're going to learn more about what that means in a second, but that's effectively what we're doing here. We are just going to be changing these words right here to better suit the level of accessibility that we want them to be that we want these variables to have outside of our class. And again, you're really going to have to just sort of lean in and trust me on some of these, sort of why this will matter and why this will long-term make sense for us. So we don't cover all of these, like we don't use all the different levels of encapsulation within our course, but there are lots of different levels. So this term right here, I'll box it in pink and then I'll write the mark in pink. The boxed pink term is known as an access modifier. All right, right there. And we actually have levels of access, not just public and private. There are more levels than just the two. We do have public. And public does mean anybody has access, anybody can do anything to it. So if we have anything that says public, everything can sort of view the data that's inside a public variable, or anybody can call a method that is publicly available. The next one that we have is private. Now, private is different. Private is privately scoped. So within a class, if you have a variable called private, just as I did over here, only methods inside this class can actually use dot notation and get that variable out. So it's not that we can't use it potentially in other ways, but before in our old notes, we would do things like write account A equals new account. And then we would say account num equals 1, 2, 3, 4, 5. And that was acceptable. But now, pardon me, now I'm telling you that this would not be acceptable in a private variable. So when this word changed to private, you no longer could write this word down here. All right, let's just erase that and keep going here. Okay, after private, we have two others, technically three others that you can do here. We have, two others. We have protected. Now, protected you won't actually see this year. It refers to sort of the folder level that your code is in. So when we have lots of different files that live in a folder, we could also have lots of different files that talk to each other that live in different folders. And protected would allow any class files that share the same folder to access the information, but not necessarily files from different folders. But we don't really see that in 1020. So I'll just say not in the 1020 course curriculum, as of right now anyway. And then we also have to think about the fact that previously we didn't put any term there at all, right? We had nothing there. It's also known as default. And default is also a bit like this idea of package protected. So for all intents and purposes within our course, default is same as public for us. I want to add that this public, protected, and default all do sound the same with respect to what we do in this class. And that's because with respect to what we do in this class, they are the same. Protected does have an additional sort of accessibility on it that has to do with, so more accessibility. Accessibility with respect to the topic of inheritance. We do not cover this topic in this course. So for us, we basically treat public, in this course, public, protected, and this idea of default, they're all getting treated exactly the same. And that's why we really only focus on private and public in this course. Okay, so we've now seen that I could do something like this, right? I could make a class like that. So let's write some code. Let's do a public class account again. With that private int account number. And we'll set that account number in a public constructor, int ID, account number equals ID. And let's close that up. A reminder that this would live in the account.java file. And then on the other side, we would have a public class main. Over here, we'd have our public, I'll try to write it all out this time instead of my shorthand, static void that should be a lowercase m, main string array arguments. Okay. And previously we did this. We did an account, A was a new account, 1, 2, 3. And if we wanted to print it, we would say system.out.println a.account num. And just to make sure that this is all correct, we're going to put main.java up here as well so that we understand that that lives in a different file. Okay, so this is what we had previously, where we would go, we'd create an account. The account A would now have a field associated with it, the account num. We pass in that data into the constructor. The constructor then sets account num equal to that value, so to 1, 2, 3. And then it's all stored inside A. And then we would say system.out.println a.account num, and we would want this to print out 1, 2, 3. Now this code will not compile. And this code will not compile because account number is private, and that means that we cannot use dot notation, like accessing our account number just like this, outside of this account class. So now what do? How are we going to actually get this information out so that we can use it? Well, we have some options, right? We could make a method internally here, public void print number, and this would do this line. Only instead of this A, we're already internal, we would just say account num. There we go. And now over here, I could say a.print num. And now when this line runs a.print num, we go into the print num associated with A. So it comes right into here. Within this print num, we have system.out.println, and it prints the account num. It goes looking for this variable account num. It does not find one locally scoped, so Java goes looking for one. It finds this one. And as we know, this account num did get set in the constructor to that 1, 2, 3 variable. So this will print out 1, 2, 3 successfully. So that's great. Now, what if we wanted to get that account number out, but we didn't want to print it? What if we wanted to get it out and actually do something with it? But we still want to maintain that this is private. Well, this is when we would add something called a getter. Let's add another method down here. We're going to add a getter. Now, we have two different types of ways to manipulate private fields within an account, within a class. We have getters and we have setters, or accessors and mutators. So our getter has the return type that matches, I'll highlight, it matches the return type of the variable we're discussing. It always has the word get because it's a getter. Whoops, that was supposed to actually be in a highlighter. And then it will have the name of the variable that we're trying to get. Now, the name itself is really, it's standardized somewhat, but it's not like enforced. And then we can just say return account num. Okay, and so now this is what is known as a getter or an accessor, because we're accessing the data. And we can now go back over here and do system.out.println. And while we cannot use dot notation to access the variable account number because it is private, we can use dot notation to access the method because the method is public. Just like the method was public for print num, so we were able to do it here. We can now get act num and return back out that integer, store it in a variable, or print it directly to console. Get account num. There we go. Okay, so now we can see that we can include these accessors. Now what if we wanted to be able to change this information for some reason? If we want to be able to change this information, we'd need another method. Because again, it's a private variable. So we need a setter or a mutator that is a public-facing method. Setters and mutators are typically void. Set the name of the variable. So again, I'm just going to highlight the word set because that's pretty typical, the name of the variable. And this is when you'd pass in your new value and you would set your account number to your new value that got passed in. That's our setter. So now if we come back over to our main, and for some reason we want to change our account number, we could say a.set account number, pass in the new number, and then system.out.println a.get account number. All right, there we go. So we can now look at this code here. I'm just going to extend that a little bit. And we can see that we make our new account with 123. We print the number out. So right here, it would print 123. We call system.out.println on a.get account num. So it's going to call .get account num on the variable a. It returns the account number, which we know is 123. That gets plopped right in here and gets printed. Then we call a.set account number, calls into this method here, passing in the parameter 456. That goes right here. And now we're saying change the account number that is associated with the variable that we called this on, right? We called it on the object A. So this is A's account number down here. Let's change it to be equal to whatever this parameter is. So now the account number will be 456. And then when we call system.out.println a.get account num, this is once again going to call get account num over here. But account num has now been changed. It's 456. So this will print 456. If at this point you are asking yourself, what the heck is the point of making something, private if we can make these accessors and mutators to get it out anyway? That's a very, very, very good point. What we're going to take away from this right now is only make accessors or mutators if you need them. Need them. Okay, so all of our variables should be private. All class instance variables are private. That's important. And we need them to be private always. So that becomes our new default, but we're only going to actually make these if we need them. If this was my whole program, we can see right there, if this was my whole program, we can see very clearly that I never call the setter. So you know what? In this program, I probably shouldn't make a setter. So I wouldn't actually include this code. So really what this comes down to is not, well, if I'm just going to make getters and setters, I should make everything public. Well, because that's true. Yeah, if you're going to make getters and setters, make everything public. But we just don't make a getter and setter for every single variable. We only make what we actually need. That's it. We use our setters to enforce rules to keep objects valid. So if we want to be able to change the account number, we could make a setter and internally have some logic. We could say like, if the new account number is valid, if it hasn't been used by anybody else, as long as it's not a negative number, right? We could use this space for good to store logic in there. But if we don't need a setter, if we're not allowing people the ability to change their account numbers once they've been set, then we're not doing that. And in fact, that's how banks work. You can't change your account number once it's been set. If you lose your bank card, they don't just change the card number. They actually cancel your card, and then they make you a brand new one. So it's not just a matter, and then transfer your money over and stuff, right? It's not just a matter of, oh, we're just going to call a setter, but they actually deactivate the old account. They move all the money into a new account. Lots of things are happening behind the scenes. It's not just a set. So it's very interesting to kind of think about. So this idea of encapsulation and these access modifiers, they're protecting our data, right? Encapsulation protects the data. That's the concept of it. And then our access modifier is actually what's controlling our visibility. So these two concepts are what are going to complete this week's core sort of topics. We've covered classes in general and the idea of objects. We've covered fields and methods. We've now also covered constructors and the idea of using encapsulation with accessors and mutators, or getters and setters, to control our visibility and protect our data appropriately. Next week, we'll continue this discussion around objects, where we will do some more advanced sort of techniques and cover some more advanced topics. If at this point you're still feeling a little bit confused around objects, I've said it before and I'll say it again, the best way to get good at this stuff is to practice. So look around your room and make some objects. Maybe you make a bed object, or a lamp, or maybe an animal. Make sure you assign it some private variables. Make sure it has a constructor, and make sure it has a method of some kind. Lost the word method there for a second. Then go and create your main class on the other side. Make another file, make your main class, make your main method, and start exploring. Start exploring. Write yourself some code that will allow you to keep track of an array. We're going to do arrays next week with this, but like if you really want to get ahead, an array of animals in a vet office. Or maybe you just make a single animal that is your pet and display its name. Maybe you have a function that exists in the lamp class where you have a variable like is lamp on, and it can return a Boolean, true or false, yes or no. And then you also have a turn on and a turn off function that you write yourself. And pretend like we're making a little circuit board program for controlling a lamp, right? There is objects all around us, so there's absolutely no reason for us to not, turn to our computers now and start exploring and creating. I will see you in next week's videos on more advanced object information. And thanks for tuning in. See you next time. Bye.